class variable also, we have to, in the same class also, we have to use class name. When we have to use like that? Both the names are same. Class variable name, local variable name same. If you want to access class variable, class name required. Okay, that is. Also, when we have to use instance variable, when we have to use class variable, when we have to use local variable, you studied. When we have to use instance variable, if the value is different to objects. When we have to use class variable, if the value is same for all objects. When we have to use local variable, to perform the task. Suppose employee number, which type of variable required? Name. Company name, class variable. Salary, instance variable. Bonus, local variable. Net salary, local variable. Like that, again, calculation part is there, go for local variable. Like that, you have to select. Okay. Instance variable, when we have to use class variable, when we have to use local variable, when we have to use dissolve, you studied. Okay. If I create 100 objects, how many copies of instance variable created? 100. How many copies of class variable created? One only created. If you create 100 objects also, one copy of class variable only created. Okay. These all points, don't forget. See, with this point only yesterday I asked a question. Very few people given right answer. Okay. Just 11 members given right answer, that is. Okay. Separate copy of instance variable exists for every object. Only one copy of class variable exists for all objects. This point. Okay. If you create 100 objects, 100 copies created instance variable. Class variable, just one copy created. Okay. This is a given clarity complete. Okay. By mistake, instance variable place class variable place instance variable. If you write, many problems will occur. You have to take care. The selection is, you have to do your duty. You have to select properly. Okay. Now, suppose, what is the execution priority? Class variables, static blocks, next main method. Okay. Can we create object without object reference? The type of object is called anonymous object. We can also call unreferenced object. Okay. Now here integer x equal to 10. Which type of variable? Static integer y equal to 20. Class variable. Integer z equal to 30. For loop integer I equal to 1, I less than or equal to 10, I plus plus. I which type of variable? Which variable? Local variable. Inside a method only, that is also local variable. Okay. Now here it is instance variable. Okay. This is class variable. This is local variable. This is local variable. But little bit difference is there between I and Z. What's the difference? I'll show you. Little bit different. This I, we can call it as block variable. Local variable also right. And this args also one variable. It is actually called a method parameter. Here, first you write this one as it is. As it is, write it. Instance variable, class variable, local variable, block variable, method parameter. Instance variable, class variable, local variable, block variable, method parameter. Just as it is, write it. Instance variable, class variable, local variable, block variable, method parameter. Just note down. Method parameters and block variables are also called local variables. Method parameters and block variables are also called local variables. Method parameters and block variables are also called local variables. So block variable, method parameter, we can call it a local variable only. Local variable only. But little bit difference is there. What's the difference? I'll explain. Okay. Is it over? See. What's the difference? I'll give. Variable life. Life of the variable I'll explain. See, instance variable. Instance variable life. Whenever object is created, then memory allocated. Whenever object is destroyed, memory deallocated. So, as long as object is available in memory, that variable is available. Once if the object is destroyed, that variable vanished. So the life of this variable is object. As long as object is available in memory, that variable available. Once if that object is destroyed, that memory vanished. Okay. Next, class variable. Class variable memory allocated whenever class is loaded. Class variable memory deallocated whenever class is unloaded. So as long as class is available, up to that class variable available. Local variable. Whenever method is called, memory allocated. When method is terminated, that is vanished. As long as method is available in memory, that variable available. Once if that method is terminated, that memory vanished. Next, method parameter. Method parameter also method only. But block variable as long as block only. Block. So for loop started, then that I variable memory allocated. When for loop terminated, that memory vanished. But local variable means in the entire method you can access. But block variable scope is limited. Life is very less, lifespan is very less. See, in this example, this I value within this for loop only we can access. The scope limited. Scope is same for these three, but these two different. I'll give. Next, scope also I'll give. Scope. Block variable scope is limited to block. Say, block variable scope is limited to block. Within that block only you can access. Outside the block, if you write error. Okay. Method parameters and local variables. Scope is limited to method only. So within the method only we can access. Outside the method, if you access, error. But instance variable, class variable different. Instance variables and class variables scope is based on access modifiers. So in the Java, 4 access modifiers are there. We'll study further. Public, private, protected, default, like that we have. Based on that, it will be different. So life is for all instance variable, life is same. But scope will be different. Based on access modifier, scope will be there. Scope and life is different. What's the difference is, whether the variable is there or not. If it is there or not, that is called life. Whether it is accessible or not, that is called scope. It is there, but we cannot access. Life is there, but we cannot access. Like that also we can restrict. It is there in the memory, but we cannot access. We can restrict. So, it is there or not, that is life. Whether it is accessible or not, that is called scope. Life different, scope different. But block variables, method parameter is all, it appears like a same. Block variable, scope is limited to block. Block variable life also block only. Whenever block started, that variable memory allocated. Whenever block terminated, that memory vanished. That is within the block only you can access. But instance variable, class variable different. Now, based on access modifier, scope will be there. All instance variable, object, whenever object is created, then only allocated. But scope is different. Private is there one type, public is there one type. That you will study in further sessions. Today not possible. Okay? Just write is all. Everything write it. Now as it is write it. Variable, life, scope, this all write it. So how to access and when we have to use instance variable, when we have to use class variable, when we have to use local variable, life, scope, everything explained. Okay. How many people completed assignment? 1, 2, 3. See how many days over assignment? 5 days over, no? When I give an assignment? Up to Friday I give time. Up to Friday I give time. So still 2 days is there. At least you try to complete. Okay. At least up to Friday you try. If you don't get, I'll teach. I'll teach. Definitely I'll teach. But you have to try. Okay. Now, instance variable, class variable, local variable, method parameter, block variable. Method parameter we can call it as local variable. Block variable we can call it as local variable. Only life point of view, scope point of view, somewhat difference is there. Remaining all same. Okay. Remaining all same concept. Now, is it over? Suppose this I value, if I print here, this I value, if I print here, system dot out dot println I, if I write, it is error, because this variable scope is limited to block only. Outside the block you cannot access. Outside the block we cannot access. If you access, you'll get an error. Okay. Now next concept, note down. Next, arrays. An array is a collection of similar data elements. An array is a collection of similar data elements. An array is a collection of similar data elements. An array is a collection of similar data elements. Array index always begins with 0 and ends with size -1. See, what is array? An array is a collection of similar data elements. An array is a collection of similar data elements. Array index always begins with 0 and ends with size -1. In Java, array itself an object. What is array means? It is collection of similar data elements. With the diagrams I'll explain. Array index always begins with 0 and ends with size -1. In Java, array itself an object. Array reference is called as an object reference or reference variable. Array reference is called as an object reference or reference variable. I'll explain. Declaration, syntax. Data type, array reference, array operator equal to new data type. Data type, array reference, array operator equal to new data type size. Examples: int a array operator equal to new int of 5. Like this also you can write. Int array operator a equal to new int of 5 also you can write. Int, like this also you can write. Declaration examples: so array operator After array reference also we can write. Before reference also we can write. After data type also we can write. 3 places we can write. These all valid. Okay. But right side should be like this only. Right side should be like this only. Right side. Right side after int only or write. But left side only 3 different types you can write. Year also valid. Year also valid. Year also valid. 3 places. If you write like this, 5 elements memory allocated. If you write like this, 5 elements memory allocated. Here, see what will be happen. Just listen. Declaration. It is declaration syntax. It is declaration syntax. New. It is a dynamic. It's a dynamic memory allocation operator. Okay. It allocates a memory for 5 integers. 5 integers allocated. By default, zeros will be stored. By default, zeros will be stored. Like this. Now, new dynamic memory allocation operator. It allocates a memory for 5 integers. By default, all zeros are stored. Array index starts with 0, ends with size minus 1. So 4, 5 minus 1. Now, this array itself an object. This is like an object. Integer array object. This object referred by A. So A. Here hash code stored. You already studied every object has an address. The address mapped into another code. That code implemented with hashing technique. That code is called hash code. That is going to be stored in A. So here, according to all points, whatever I given, just observe. Array. What is array? Array is a collection of similar data elements. Similar. Nothing but 5 integers or 10 integers or 5 floating point numbers, one type only. Multiple means class. One type only. All integers or all floating point numbers or all like strings. All like a boolean. One particular type only. Collection of similar data elements. Same type of elements. That is array. So new integer of 5. If you write, it is a dynamic memory allocation operator. What it will do is, it allocates a memory for 5 integers. New is a dynamic memory allocation operator. It allocates a memory for 5 integers. All are integers only. Array itself object. It's an object. Index starts with 0. Ends with size minus 1. 5 minus 1, 4. So 0, 1, 2, 3, 4. It is index. This is index. This is element. We can call it as element. Okay. Now, here you observe. Right side array created. Left side array reference created. Array, whenever you call it as this is array, this is called array reference. Whenever you call it as object, this is called object reference. Whenever you call it a data type, it is called variable. Reference variable. Okay. Like this we'll call. This is declaration diagram. Note down. By default, zeros are stored. By default, zeros are stored. How to assign values, how to initialize values, I'll explain. Is it over? See, by default, all zeros are stored by default. So for every data type, one default value is there. That is I'll give. Next node. Now next write it. Data type default value. Data type one default value. First one byte. Second one short. Third one int. Fourth one long. Fifth one float. Sixth one double. Seventh one char. Eighth one boolean. This already you know. Byte default value 0. Short default value 0. Int default value 0. Long default value 0. Float default value 0.0 f. Double default value 0.0. Char default value blank space. It is nothing but ASCII value 0. Boolean default value false. Boolean default value false. So for every data type, one default value. By default, nothing but all zeros only. Here, you already studied character. Character 65 number, capital A. 97 small a. Like that, 48 means 0. Like that, 0 means blank space. 0 means blank space. So ASCII value 0 is a default value. 0 means blank space will be there. That's what blank space comes. False means generally 0. True means 1 the type. But it will not understand in Java. False is a default value in Boolean. Okay. You already studied. Boolean cannot be converted to other types. Other types cannot be converted to Boolean type. Okay. So false means 0. True means 1. Like that also not possible in Java. But here default value false comes. Now see. These are default values. By default, you'll get it like this. Suppose example, is it over? Here, by 0.0 f, here. Long 0, if more than integer range is there, L required. Otherwise not required. But 0 within the integer range only, no? Starting sessions are given. If the number is out of integer range, then L required. Small l or capital L. But it is within the integer range, not required. Okay. Now, suppose you observe here. If I don't write any value, now, is it instance variable or class variable or local variable? What is? Instance variable. How many ways to access? 2 ways. What are those? Object, object reference. Which class object required? That is which class? It is a member of demo class. Then demo class object only required. Okay. Now, I want to access. What we have tried? Give me answer. System.out.println. What we have tried? Demo.x. Now this x is which type of variable? Instance variable. How many ways to access? 2 ways. What are those? Object, object reference. I want to access with object. What we have tried? What we have tried? New demo.x. New demo.x. Okay. New demo.x. Okay. Now, this y, which type of variable? Which type of variable? Class variable. That is class variable. Okay. How many ways to access? 4 ways. What are those? Directly, class name, object, object reference. Now, can I access directly now? Yes, we can access directly. So, system.out.println y. If I run, you will get a both are 0. See, file, save. Now, I'll open command prompt. See, here, Java C demo.java. Java demo. You are reading both are zeros. Here, suppose if it is local variable. Okay. Now, local variable, how many ways to access? 1 way. What is it? Directly. But if I write this one, error comes. A local variable compulsory we have to initialize. That is also one point is there. See, variable z might not have been initialized. X also not initialized. Y also not initialized. But you will not get error. But z you are getting error. So here note your right. Local variables must be initialized before access. Otherwise, compile time error occurs. Local variables must be initialized before access. Otherwise, compile time error occurs. Local variables must be initialized before access. Otherwise, compile time error occurs. So what you do is, before going to that arrays program, you write this one also. Is it over? Just you write here output is 0. Here output is 0. Here error. Okay. Write that program. So instance variable, class variable, you'll get a default value, but local variable must be initialized. Why you'll understand while teaching constructors, while teaching static blocks. Say this is default value 0. This is default value 0, but this one compulsory we have to initialize, otherwise error. Suppose if I write here Boolean, what is the output comes here? False. Okay. If I write Boolean, it is a false. Suppose here if I write character, what will get? Blank space. Blank space. See, this is not possible. I'll remove. This I'll remove. Now you observe. This is false. This is blank space. File, save. Compilation, execution. See, one false is there. Blank space also is there. Okay, blank space. So, if you write true, Boolean means false. Char means blank space. Now, there's no need to write. Just already given this one. Now, this array if we declare, by default all zeros are stored. But if you want to assign, next write it. Array assignment. Array assignment syntax. Array assignment syntax. Array reference. Array reference. After this, index equal to literal. Examples. A of 0 equal to one number. A of 1 equal to one number. A of 2 equal to one number. A of 3 equal to one number. Like this you can write. So, assignment. So starting 0, later 34, starting 0, later 93, starting 0, later 13, like that you can write. But at a time if you want to write, it is also possible. Initialization. Initialization. Initialization also possible. Syntax. Data type. Array reference equal to literal 1, literal 2, n number of you can write. Examples. Integer, some x equal to, you can write. Like this. You can initialize. It is array initialization. Is it over? See, till I didn't explain how to accept data from keyboard dynamically like a scanf function. Because in Java it is different. Scanner class object dissolve, without dissolve not possible. I'll explain further. Now array declaration assignment. That means initially 0, later these values. But directly if you want, directly also you can possible. It's possible. You can initialize directly. But here new integer is optional. If you write also valid. I'll show you both the syntaxes. See, for example, here integer array operator a equal to new integer of 5. If I write, it is valid. This array operator you can write here also. This array operator you can write here also. Same style, here main method argument is there, no? This array you can write here also, you can write here also, you can write here also. All are valid. All are valid. If you write like this also valid, previous one also valid, previous one also valid. You can write like this also. But till I didn't explain about main method. Okay, later we'll see this one. Now you can write like this also. You can write like this also. You can write like this also. All are valid. Okay. After this, here, if I print system.out.println a, now give me answer. What will be the output comes? Think yourself and give me answer. Zeros. Any other? What is it? 1 0, 4 zeros, 5 zeros. Any other? Hash code. Hash code comes because already given what array reference contains. Hash code. Array contains elements. What do you mean? Hash code is output. See, file, save. See, compilation, execution. That is hash code. Hash code in hexadecimal format comes. That is no use. So if you want to print elements, we need to print like this. We have to use loop. Compulsory we have to use loop. So if you write like this, what will happen? 5 zeros are stored. If you want to print, how to print? See, for loop, integer I equal to 0. Array index starts with 0. I less than 5. I less than 5. But this is also no need to write in Java. Array reference dot length. It is automatically it will take. If 5 is there, 5. 10 is there, 10. 20 is there, 20. Automatically it will take. After that, I plus plus. Now you can print. System.out.println a of I. It will print. Okay. Now you observe. If I write like this, what will happen? See. If I write like this, what will happen? See. 5 elements array created. Okay. Now here 0, 0, 0, all zeros are stored. Okay. Now these all are by default zeros. All are by default zeros. It is index 0, 1, 2, 3, 4. This is one array. Okay. This is one array. Integer array object. This object referred by A. Okay. Now, when first line is executed, new, it is a dynamic memory allocation operator. It allocates a memory for 5 integers. 5 integers memory allocated. By default, all are 0 stored. Okay. This 1, 2, 0, 1, 2, 3, 4. It is index. Index. This 0 nothing but element. That is terminology. Element. So it contains hash code, address. Address mapped into another code. That code implemented with hashing. That code is called hash code. Okay, that is stored. Now, first I value 0. 0 less than 5. It is automatically takes. Length if you write automatically takes. 0 less than 5. True. A of 0. This 0 printed. A of 0. Later I becomes 1. 1 less than 5. True. A of 1. This 0 printed. A of 2. Like this 0, 0, 0. All zeros printed. But if you want to see, if I run file, save. compilation, execution, all zeros. But if you want to assign the value, a of 0 equal to one number, a of 1 equal to one number. Okay. Now a of 2 equal to one more number. Like this. If I write, now remaining zeros comes. Now you observe, if I write these three numbers comes, remaining two zeros comes. File, save. See, compilation, execution. These three printed, two zeros. Here declaration is there, assignment is there, and accessing is there. Once again I'll explain, just listen. See, when first line executed, 5 integers memory allocated. 5 integers memory. Okay. New, it is a dynamic memory allocation operator. It allocates the memory for 5 integers. By default, all are zeros. By default, all are zeros. Array index starts from 0. Ends with size -1. 5 - 1, 4. Like this. Array itself object. Array itself an object. Which object? Array object. Integer array object. This object referred by A. This object referred by A. What this A contains? Hash code. This A contains hash code. Which contains hash code. Okay. After this, A of 0 equal to 34. A of 0 equal to 34. This will become 34. Okay. A of 1 equal to 43. A of 1 equal to 43. It will become 43. A of 2 equal to 99. It will become 98. 98. After this, now for loop, how it is executed already you studied. So first this one executed. Int I equal to 0. After this, 0 less than 5. This length automatically takes 5. True. It will enter. It will enter into loop. Okay. System.out.println A of 5. A of 0. 34 printed. So output 34 printed. After printing 34, from here control comes to I++. From control comes to I++. I will become 1. 1 less than 5. True. A of 1. 43 printed. A of 1. 43 printed. Again I becomes 2. 2 less than 5. True. A of 2. 98 printed. 98 printed. I becomes 3. 3 less than 5. True. A of 3. 0 printed. I becomes 4. 4 less than 5. True. A of 4. 0 printed. Later it will become 5. 5 less than 5. False. False means out of. 5 less than 5. False. Then out of for loop. Okay, like this works. So if you want to print array elements, compulsory loop required. Okay, write this one. So in this program, array declaration is there, array assignment is there, initial printing is there. So accessing with for loop. Can we access with the while loop? Yes or no? While loop also valid. For loop also valid. Do while also valid. Any loop we can use. With while loop, I'll explain. I'll ask question, give answer. With your answers, I'll write the code. With while loop. Okay. If you want, you can write the diagram also. For loop iteration also. Is it over? So in first line, array created. In first line array created. While creating by default all zeros. Later I assign 3 values. Remaining zeros only will be there. With loop we can access. But system.out.println A if you write, you will get a hash code. Because A contains hash code. It is reference type. You already studied. One point I given. Primitive type variable contains data. Reference type variable contains hash code. That is I given. Now this A is a primitive type or reference type? Reference type, because array operator. Seeing this array operator, you can give answer. It is reference type. Okay. If only int is there, primitive type. Integer array operator is there. That is reference type. Any reference type variable which contains hash code only. Array reference also, string reference also, object reference also, everything hash code only. Okay. Is it over? Now I'll initialize array. Now I'll initialize array. You observe. Integer array A equal to, I'll initialize. See, like this I'll initialize. You can initialize like this also. But we can also write like this also. It is also valid. See, file, save. If I compile, it will compile. If I remove this one also, it will compile. So, while initializing, new operator not required and data type not required. Based on this data type it will understand. New, based on these elements only allocates a memory. If 5 elements are there, 5 allocated. 10 elements are there, 10 allocated. So you can initialize like this also. You can initialize like this also. Both are valid. Both are valid. Okay. Now, if you write like this also valid. If you want to print these elements by using while loop, what we have to write, give me answer. With while loop I want to print. What we have to write? Int I equal to, give me answer, 0. Next, while I less than array reference dot length. Next, system.out.println A of I. After this, I plus plus. That's it. It is nothing but this line will write here only. This line will write here only. We'll write for. That is only for loop. Now, before while loop, initialization. Inside the while loop, updation. All later time if you write for loop. That's it. See, this line you can write here. Integer I equal to 0. Here I plus plus. You can remove this. You can remove this. Just you can write here for. Over. It is for loop. It is for loop. And even you can write for loop like this also. You observe. You can remove this. Here integer I equal to 0. This I plus plus you can remove here. You can write I plus plus. But thing is 2 semicolons compulsory. If it is for loop. Here semicolon compulsory. Now if you want to make it while, just while, remove semicolon. While teaching loops I explained already. Okay. Now file, save. If I compile, see, compilation, execution. Write this one. Here array initialization, accessing I given. Here also individual element only printed. Loop iterated many times. That's what many times printed. Like A of 0 you can print. A of 1 you can print. A of 2 you can print. But that also possible. Without for loop means you can write 5 statements. Now this is array or this is array. A is array or array reference? Array reference. Right side is array. Okay, right side is array. Left side is array reference. Got in mind? Right side is array. Left side is array reference. Okay. Now next point, enhanced for loop. I given loops. One loop I didn't explain. That is required now. Enhanced for loop. We can also call for each loop. It is used to iterate elements of an array or collection. Collection we'll see later. Array. It is used to iterate elements of an array. Syntax. For data type, variable, colon, array reference, open brace, close brace. This loop introduced in JDK 1.5 version in 2004. So enhanced for loop. We can also call for each loop. This loop introduced in JDK 1.5 version in 2004. Previously it was not there. First version it was not there. JDK 1.5 version it is introduced. This loop introduced in JDK 1.5 version 2004. This syntax is very simple. No condition, no logic. Just you need to write one variable, you need to write array reference. From that array, one element copied, automatically printed. I'll show you. This is not a normal for loop, enhanced for loop. That for loop enhanced with new syntax. That's what enhanced. Otherwise, one element iterated. That's what for each loop. Like that also you can call. You can call it as enhanced for loop, or you can call it as for each loop. Both are valid. That for loop only enhanced. That is the reason enhanced for loop. One element iterated. That's what for each loop. Like that terminology, both are valid. You can call it as enhanced for loop, or you can call it as for each loop. Okay. It is very simple. No condition, no updation, no expression. Only data type, variable, array reference. See, previous for loop, I equal to 0, I plus plus conditions, operations are there, no? That is nothing here. How it works, I'll explain. See, suppose it is another syntax, I'll show you this syntax. New integer, it is also valid. Now, for data type, which array? Integer. So one integer, B, colon, A, over. Now, what will be happen is, this array reference refers this array. From this array, automatically one value copied in B. The B you can print. That's it. So automatically one value copied in B, printed. Next value copied in B, printed. Next value copied in B, printed. Like that works. File, save. Compilation, execution. See, all elements printed, no? It is best one for arrays, but this is not suitable for other concepts. It is only for arrays. And collections framework, one more topic is there. At the time also we can use. Arrays and collections only, it is suitable. So from this array, one element copied in B, that B printed. But we are not writing any logic, any condition. You observe. If it is normal for loop, int I equal to 0, that is initialization expression. I less than a dot length, that is condition. I plus plus, updation. 3 expressions we are writing, but here no expression. It is only array reference. From that array, one element copied in B, that B printed. That's it. See, file, save. Compilation, execution. Okay, write this one. Example. Example, write this one. We'll see continuation tomorrow. Tomorrow, we'll see continuation. So we'll see continuation tomorrow.